Okay. Now next, few more doubts. One more student send me doubts regarding this probability. Let me finish. Then again I will continue the complex numbers. Here the doubt is, here they given total number of, listen, total number of ways, total number of ways in which five balls of different colors, they mention different colors, five balls of different colors can be distributed to, can be distributed to, can be distributed to among three persons, among three persons, so that each person gets, each person gets at least one ball. Okay, so this is the concept basing on permutations, combinations. But the thing, they will modify this bit, simply find the probability, they will add like that. Find the probability if the number of ways of distributing five different balls to three persons, okay, so that each person get at least one ball. Then how you can find the probability? So here x1 plus x2 plus x3, let x1 be the balls, number of balls received by the first person, x2 is the balls received by second person, x3 is the balls received by the third person, is equals to 5. Can I proceed like this? Can I use this multinomial theorem concept for this bit or not? That is my question. Okay. Can we use ma? No, we can't. The thing is, if they mention five identical balls, very, very important. Okay. Keep in your mind. Competitive point of view, exclusively IIT point of view, JEE mains point of view, very, very important. Here if they mention identical balls, five identical balls are distributed to three persons, find the number of ways so that each person get at least one ball. Then automatically here what is the value? Number of positive integral solutions you will get. What is the number of positive integral solutions formula? N minus 1 C R minus 1. This is the formula. There only it will ends. But here according to given data, five balls of different colors, they are not identical. Important point. Five balls are different colors distributed to three persons. Distributed to three persons. Each can get at least one ball. So here mom, 1, 2, 3, 4, 5. Here it is A1, A2, A3. So these are also different. These are also different. Indirectly, what is the concept behind it? Number of onto functions. Here we have to find number of onto functions. For this number of onto functions, already we given the formula. What is the formula for this one? N of b to the power n of a minus n of b c1 into n of b minus 1 power n of a. Like this one formula is given, you can cross check one time. This is the favorable cases you may get. Then what are the total cases indirectly here? For this bit, if they will ask probability, then the total cases are nothing but total number of functions. Total number of functions. How you can find the total number of functions? What is the formula for total number of functions? N of b to the power n of a. So here the total functions are given by 3 power 5 is the value. Therefore here if they will ask probability, this value by this is the value. Simply if they will ask number of ways, means this is the value only. So This kind of bits also competitive point of view very very important. So these are the doubts ma. Few members they asked me regarding this. Next ma. Now we will continue complex numbers. Okay. Next, complex numbers. In complex numbers. Okay. Till now, de Moivre's theorem present we are doing ma. In de Moivre's theorem also, yesterday majority of the bits we discussed. There nth roots of unity. Okay, nth roots of unity, nth roots of unity, nth roots of unity. Standard category nth roots of unity. Just now we completed ma cube roots of unity. So what are the cube roots of unity? 1 omega omega square. These are the cube roots of unity. 1 omega omega square. And what is the sum of these values, mom? 1 plus omega square is equal to 0. Okay, mom. And if we did the product, what is the product value for this one? 1 into omega square, which is equals to 1. Now, fourth roots of unity. What are the fourth roots of unity? If you observe fourth roots of unity, ma, 1 minus 1 I minus I. These are known as the fourth roots of unity. And what about the sum of the values will be 1 minus 1 plus I minus I is equal to 0. And what about the product value, ma? Tell me. 1 into minus 1 into I into minus I. Then this is the value minus plus I into I square. What is the value will be? Minus 1. So here the product nth roots of unity. Product of, if you apply here the point is product of nth roots of unity. Product of nth roots of unity equal to minus 1 whole power n minus 1. Remember that value. So what is the product of the cube roots of unity? Minus 1 whole power 3 minus 1. You will get that is the value 1. What is the product of the fourth roots of unity? Minus 1 whole power 4 minus 1 minus 1 whole cube minus 1. You will get it. And at the same time, sum of, this is the first point. Second point, sum of nth roots of unity. Sum of nth roots of unity is equal to 0. Okay, basing on this one. 1 plus omega square, and here it is the value also. If you observe, this is the value is equal to 0. This is also one more point. Next point, nth roots of unity. Nth roots of unity lie on unit circle. Lie on unit circle with center at origin. This is also one more important point. When we are deriving the roots of unity, even this point also. And what is the argument difference? And argument difference is equals to 2 pi by n. Consecutive numbers I am telling. Consecutive numbers. For example, if we take cube roots of unity, what is the cube roots of unity? Consecutive complex numbers. For that means here that I told you, this is 1, here it is omega, and here it is omega square. Here the difference. What about the difference will be? 120 degree, 120 degree, 120 degree. How it come? 2 pi by 3. Since cube roots of unity, so cube roots of unity means 2 pi means 360 by 3, which is equals to 120. Similarly, if we discuss about the fourth roots of unity. Even fourth roots of unity, how they will lie? Same here also. If you observe, this is one value, this is one value, this is one value, this is one value. What is the argument difference will be 90 degree. How you can get 2 pi by 4, which is equals to 360 by 4, which is equals to 90 degree. Consecutive I am telling like this. So these are the properties of the nth roots of unity, and each value. For example, 1 comma, next one more point. 1 comma alpha square comma up to so on alpha power n minus 1 are nth roots of unity, are nth roots of unity. Then 1 power n equal to alpha power n equal to alpha square power n equal to up to so on alpha power n minus 1 whole power n is equals to 1 only. Means what is this meaning ma? Here 1 omega square are the complex cube root of unity na. What is 1 cube value? 1. Omega cube value 1. Omega square whole cube value 1, like that. Here what are the fourth roots of unity? 1 minus 1 I minus I. 1 power 4 1 minus 1 whole power 4 1 I power 4 1 minus whole power 4 1, like that. Similarly here if you take the value as 1 alpha square so on alpha power n minus 1 as the nth roots of unity, then automatically 1 power n equal to alpha power n equal to alpha square power n equal to up to so on alpha power n minus 1 whole power n is equals to 1 is the value. So these are the properties of the nth roots of unity. Now okay ma, listen. For example, one complex number is given, z equal to x plus iy, z equal to x plus iy. Now this is the concept related to Coney method or a rotation theorem. Coney method or rotation theorem. Coney method or rotation theorem. Listen ma, how you can derive this one. Very very important competitive point of view. For example, z is equal to x plus iy ma, and this x plus iy value r into cos theta plus I sin theta, let it be. So r into e power I theta. What is here r value? Where r is equal to modulus of z, which is equal to r root of x square plus y square ma. Theta is amplitude or principal argument. Okay. Now for example, somewhere origin is there, let it be. This is the real axis mom. Let this is a real axis. Let this is the complex number z is there. Let this is the point I can take as xy. Origin is here. Z is equal to r into e power I theta. What is that meaning? What about this angle? Argument means this is the value. Theta is the amplitude or principal argument. That is the complex number here. For example, if I rotate, this is the like this. If I rotate like this through an angle alpha. For example, through an angle alpha, I will rotate this complex number. I will rotate through an angle alpha. Now let this is z dash. Let this is z dash. Now we will derive the relation between z and z dash. Both are complex numbers ma. Z is here. What I did here? I rotate the complex number which is here. It is then I rotate like this through an angle alpha. Now, what about this z dash will be? Tell me, ma. Any complex number z dash, any complex number, not z dash, any complex number. How you can represent a complex number ma, in the polar form or an odd amplitude form? Modulus value we have to know, and amplitude value if you know, then we can represent the complex number. So here, if I rotate OZ like this, is any change in this magnitude value ma? That means, is modulus value of this complex number, is it will change? No. How it will change? Simply I rotate it like this, that's it. Argument will change, but the amplitude will not change. Now tell me, what is the amplitude will change, modulus will not change. So z naught is equal to same r you will get now. So r into then theta value. Is the theta value changed or not? Changed automatically. Theta, from theta to we increased alpha angle. So theta plus alpha. So how I can present that complex number z dash is equal to r into e power I into theta plus alpha. Then this whole value I can written as r into e power I theta into e power I alpha. But what is the value r into e power I theta ma? R into e power I theta is nothing but z is the complex number. So here you will get that implies z dash equal to z into e power I alpha. This is the relation between the z dash and z. This is known as the rotation theorem or Coney method. Remember this concept. Okay ma? Like in the two-dimensional geometry, these are nothing but parametric equations, r cos theta, r sin theta. That's it. Only theta is varying. Modulus is fixed. So automatically you can represent the complex number as mod amplitude form like this. Okay ma? Remember this one. Next. Even regarding this Coney method, more we have to discuss ma. We will discuss. Next, regarding the modulus of a complex number. For example, z1 is equal to r1 into e power I theta 1. z2 equals to, let it be r2 into e power I theta 2. Okay ma? So here what is r1 value ma? Modulus of z1. What is r2 value? Modulus of z2. Since that is the mod amplitude form, where r1 r2 are the modulus of the complex numbers ma z1 comma z2, that I indicated like this. Next, if I did z1 by z2, tell me what is z1 by z2 value? r1 by r2 into e power I into theta 1 minus theta 2. So this is the complex number. Of course, this value you can take as some constant only. This is r1 by r2 means that is constant only na? So here, what is the modulus of z1 by z2? This is a whole one complex number, you can take it. This is whole one complex number. Let it be z3 equal to some constant into e power I theta. What is this value? Will be nothing but modulus of this complex number only na? So modulus of z1 by z2 is equals to, what is the value you are getting ma? r1 by r2 you are getting. But what is r1 value? Nothing but ma? Modulus of z1 by modulus of z2. So remember this formula also when we are doing the simple bits. There modulus of z1 by z2 is equal, directly we can use modulus of z1 by modulus of z2 like this. Similarly, if you find the value z1 into z2, z1 into z2 equal to, tell me what is z1 into z2 value? If z1 equal to, this is the complex number, z2 is this is the complex number, z1 into z2 equals to what is value? r1 into r2 into e power I into theta 1, sorry, theta 1 plus theta 2. You will get like this na? So here z1 into z2 means this is one complex number. Let it be z3. So z3 equal to some constant into this value. So here what is this meaning ma? Modulus of z1 into z2 is equal to nothing but this is the value na? r1 into r2. But what is r1 value? Modulus of z1 into modulus of z2. These also you have to remember. So here this is one more formula, modulus of z1 into Z2 equals to modulus Z1 into modulus Z2. Remember these two formula in complex numbers. Next one. Now, till now, what we have discussed, all these things are the easy concepts. Moreover, now in this lecture, slowly I will enter into geometrical applications. Very, very important. Geometrical applications. Already till now, number of times I told you, complex numbers means nothing but two-dimensional geometry. Even few examples also I given. What is the equation of the circle in the complex form? Okay. What is the modulus geometrical meaning? What is the argument geometrical meaning? What is the conjugate of a complex number geometrical meaning? Like that, few points I given. Now today, one example I will tell you. Okay. Basing on that, slowly we are entering into the geometrical application of the complex numbers exclusively up to JEE mains level. This is enough what we given, but IIT advanced point of view, these geometrical applications are very, very important. Okay, listen carefully. With one example I will give today, 2-3 examples I will give. From tomorrow onwards in detail we will go. Here they given here they given find locus of W where W equals to Z plus 1 by Z. This is the bit they given. Find the locus of W. Find the locus of W where W equal to Z plus 1 by Z. Okay, like this they will give. We have to fix the locus of W. Of course, W is also one complex number. Let it be like that. Then what about that value will be? Listen, ma. Here if you observe, and here they will mention where mod Z is equals to some constant K. There is also point they given which is not equal to 1 something they given like that. If mod Z is equal to K, then how you fix the locus of W? Listen, ma. Let Z is equal to K into e power I theta. Already modulus Z value also in the given data only, ma. Other than 1 they given like that. So there you will get mod Z is equal to K. So let Z equal to K into e power I theta. Then from this one, what is 1 by Z value, ma? Tell me. If you calculate the value 1 by Z, then what is the value? 1 by K into e power I theta. 1 by K into e power minus I theta. This is the value, e power minus I theta, according to De Moivre's theorem. Then W equal to, let W equal to X plus Iy. Whenever, in order to fix the locus of any complex number, like in the locus bits, what we are doing, let P of X comma Y is any point on the required locus, like that we can take it. Same here also. Let I can take W is equal to X plus Iy. And X plus Iy equal to what is the given, Z plus 1 by Z. That implies X plus Iy is equal to Z. What is that value will be, K into e power I theta plus 1 by Z. What is 1 by Z value? 1 by K into e power minus I theta. Simplify, K into cos theta plus I sin theta is the value, plus 1 by K into cos theta minus I sin theta is the value. Now which is equal to, make it as the real part, imaginary part. If I separate this value k plus 1 by k into cos theta first value plus iota sin theta if you common. Iota sin theta if you common, you will get k minus 1 by k is the value. This side what is the value it is given x plus iy is the value. So x plus iy is equal to, this is the value you will get it. Now both sides equating the real and imaginary parts. Now both sides equate real and imaginary parts. Then tell me what is the imaginary part? First real part will be x is equal to k plus 1 by k into cos theta. Then with this one, if you make real part cos theta equal to what is the value x by k plus 1 by k. Next imaginary parts this is equation number 1, you may take like this. Next imaginary parts equate, if you equating imaginary parts now y is equal to sin theta into k minus 1 by k. With this one, what is the sin theta value sin theta equal to y by k minus 1 by k is the value. Therefore, what is the relation between sin and cos we know that, okay, we know that what is the value will be sin square theta plus cos square theta is equal to 1. Therefore, sin square theta, cos square theta equal to 1. What is the cos square theta value? X square by k plus 1 by k whole square plus sin square theta y square by k minus 1 by k whole square is equal to 1. What is this locus will be? X square by a square plus y square by b square equal to 1. What is this locus will be? Locus is nothing but a ellipse, like that. So geometrically they will frame the bits like this. Find the locus of w where w equal to z plus 1 by z and satisfying some mod z is equals to constant value, like this. Okay this is the one example in geometrical application. One more example I will give. Okay, next. Now entering into in detail for example, one complex number is given. For what one complex number? Listen. Argument of z is equals to pi by 6. Geometrically, what this indicates? Argument of z equal to pi by 6. If they given like that, argument of z is equal to pi by 6. What that indicates? Argument of z equal to pi by 6 means what it indicates. Listen here. Argument of z equal to pi by 6 means, let this is the argon plane. Argon plane or Gaussian plane. Argon plane or Gaussian plane. Okay, complex plane. Okay, whatever it is, you can take it. Argument of z equal to pi by 6. What it indicates? Pi by 6 means this is the angle 30 degree. So, if you take any complex number on here, on this, if you take anywhere, any complex number you can take. For that any point, what is the argument will be? Pi by 6. Now here the question is, if I mention like this, so this is the real axis, of course, this is the imaginary axis. Argument of z equal to pi by 6, I mentioned like this. Can I take this side any point? Now how you are taking in the direction? Can I take any point in this direction also? No. If you take here it is origin. If you take any point here, z if you take like this, what about the argument will be? This is the argument. But the given argument of z equal to pi by 6 means which indicates a ray. This is important. So argument of z equal to pi by 6 indicates a ray. Very, very important thing. Which indicates a ray. All these are the geometrical concepts. So argument of z equal to pi by 6 means this is a ray. Initial point is origin, which makes an angle 30 degree with real axis and forward like this only, not this side. Means argument of z equal to pi by 6 means this indicates a ray. Very, very important. Okay. Next, listen. Okay, remember this geometrical application. Now, let this is complex number z1. Let this is complex number z2. Geometrical applications we are discussing. Listen carefully. So, if I mention that like that, indicated by z2 minus z1, like how I can say, okay, leave it this concept in the next video lecture I will explain. Let me explain an example. After listening that you will get clarity. Okay, here the one example first, write down. Here the one example is find z satisfying argument of z equal to pi by 6 and modulus of z minus 2i equal to 2. This is the bit they given. Find a complex number z which is satisfy argument of z is equal to pi by 6 and modulus of z minus 2i equal to 2. Then here this is the application part of that argument of z concept I given, this one only. So in order to find one particular z value which is satisfy both the conditions, first of all we have to find what is the geometrical meaning of argument of z equal to pi by 6 and what is the geometrical meaning of modulus of z minus 2i is equal to 2. If you understand these two concepts, then automatically by geometrically we can solve this bit very easily. Okay, listen. Here it is argument of z equal to pi by 6. Already they given. Just now I told you argument of z equal to pi by 6 means that indicates the ray. And what this value indicates? Argument of z minus 2i is equal to 2. Sorry, modulus of z minus 2i equal to 2. Do it, modulus of z minus 2i is equal to 2. A solution for this one, let I can take z is equal to x plus iy. Then what about this value? Modulus of x plus iy minus 2i is equal to 2. Then simplify. Modulus of x plus I into y minus 2 is equal to 2. What is this modulus means, Modulus means nothing but root of real part whole square plus imaginary part whole square. So this value you will get a root of x square plus, here it is, y minus 2 whole square equal to 2. Then squaring on both sides, you will get x square plus y minus 2 whole square equal to 2 square. What this equation indicates, This is nothing but a circle whose center is at 0, 2, and radius is equals to 2 units. So here if you draw the diagrammatically, let this is the real axis and let this is the imaginary axis origin. Then let this is 1, 2, 3, 1, 2, 3, 1, 2, 3 this side, 1, 2, 3 like this. Now 0, 2 is the center. 0, 2 is the center. Radius is 2 units. Radius is 2 units. That means what is the circle position will be? Radius is 2 units. Na? So the circle will be, let it be, maybe, I hope that I am not good at drawing small, but I will try to give the accurate diagram. Let this is the circle. This is the circle. Whose center is 0, 2. Center is 0, 2 and radius is 2 units. Next, what they given? Argument of z equal to pi by 6. So argument of z equal to pi by 6 means that here pi by 6 making an angle here pi by 6 30 degree. It will go on like this. Let this is the pi by 6 angle 30 degree. This is the argument of z. Argument of z pi by 6. Argument of z is equal to pi by 6 means if you take z is equal to some x plus iy, tan inverse of y by x is equals to pi by 6. Therefore y by x is equals to, what about this value will be? Pi by 6. Tan of pi by 6. Tan of pi by 6 means tan 30. Tan 30 is equals to 1 by root 3. Means what about this value? Y is equals to 1 by root 3 into x. So this is nothing but y is equal to x by root 3. This is the value. Now here if you observe this ray, we have to find this is the point. Even find z, particular z value we have to find. What is the z value? Argument z equal to pi by 6. Required z lies on argument of z equal to pi by 6. But I told you argument of z equal to pi by 6 means it is a ray starting with origin and going on like this. And if you simplify, of course, pi by 6 means if you take z is equal to x plus I, argument means tan inverse of y by x is equal to pi by 6. Automatically y by x is equals to tan of pi by 6. Tan 30 degree value 1 by root 3. You will get the value y is equal to x by root 3. So you got this is the ray as like this. Therefore, and one more thing, our required z satisfy this circle equation also. Means our required z lie on this ray and our required z lie on this circle. Then solve them. How you can solve it? Simple. Y is equal to x by root 3. Therefore, x equal to root 3y. X equal to root 3y. Replace x equal to root 3y in, let this is equation number 1, you may take it. Equation number 1. Then simplify x square. X square means what you will get 3y square plus y minus 2 whole square is equal to 4. If you simplify this value, 3y square plus y square plus 4 minus 4y is equal to 4. 4 get cancelled. Then here it is the value 4y square minus 4y is equal to 0 is the value. Therefore, y square minus y is equal to 0 means y is equal to 0 or 1. Of course, here it is the value 1 you will get it. So y is equal to 1 you will get it. If y is equal to 1, what is x value will be root 3. So the point is root 3 comma 1. That's it. So this is the geometrical application of the complex numbers. Complex numbers. Here simply they will give find z. If it will satisfies the condition, argument of z equal to this value and modulus of z minus 2y equal to this value. So here to fix that particular z value, first of all we have to know what is argument of z geometrically and what is modulus of z minus 2y value equal to 2 geometrically. Then what we here we did all these equations what they given in the complex plane, we are converting them into Cartesian forms. After converting into Cartesian form, then it will be easy to calculate what the required value. Okay. I hope that you can understand this one. Okay, next ma. One more example. Here the example. Here they given. Next example. Z satisfy modulus of z minus 3 is equal to 4. Then find minimum and maximum of modulus of this is the bitmum. Okay, here they given z satisfies the condition modulus of z minus 3 is equal to 4. Okay, then find minimum and maximum of modulus of z minus is the value. So first of all, while entering into in this bit detail, what is the geometrical meaning of modulus of z1 minus z2? Okay, first I will tell you this is the value. What is the geometrical meaning of modulus of z1 minus z2? Simple ma here. Let if you take z1 is equal to x1 plus iy1. Let z2 equal to x2 plus iy2. Then what is the value ma? z1 minus z2 equal to x1 minus x2 plus I into y1 minus y2. Now, modulus of z1 minus z2. What is the modulus of the complex number? Means root of real part whole square plus imaginary part whole square. So here I can get x1 minus x2 whole square plus y1 minus y2 whole square. So now you can understand what is the geometrical meaning of modulus of z1 minus z2 mom? Distance between 2 points z1 comma z2. This is the logical meaning of the modulus of z1 minus z2. So whenever if they given modulus of z1 minus z2 means ma, algebraically we can do calculation, but the geometrical meaning is nothing but distance between these 2 points z1 z2. Remember this one. Now here what they are asking, if you observe the given data, z satisfies the condition modulus of z minus 3 is equal to 4, and then find the minimum and maximum of z minus 7i. Now maybe here if you observe, for this one they are asking minimum and maximum. Just now I given modulus of z1 minus z2 means distance between the two complex numbers. So here they are asking what is the minimum value of modulus of z minus this value. Indirectly here the concept is you have to find the minimum and maximum of the z from the point 5 comma 7. Here 5 plus 7 they given. 5 plus 7 means nothing but 5 comma 7. Then here z is one point. For that particular point from 5 comma 7, what is the max value, what is the minimum value? That thing we have to find it. Now that where the z will be lying according to given data, z satisfies the condition modulus of z minus 3 is equals to 4 is the value. Okay, try yourself. Next we will proceed. Thank you.